got working on an LED conversion project. These are Tento 3 watt 250 LM bright white LED lights. It's basically like a little diffuser, but what I liked about them was they're pretty thin. And you can see I don't have a lot of space in between the roof and the head of the thing here. So what I've got was one power source here. So I'm going to be installing this LED dimmer and light switch, so I can have an independent switch that'll be here just temporarily until I get something that'll fit down here, but I just want to test it. And then what I did is I used this light here as the main pull line, so I brought one feed to here, and then from here I went to the 4 lights, and then I've got another couple more and then I'm going to put in as a second phase. I just wanted to make sure that there was enough light when I turn them on. And then on my meter here, I'm able to actually check the current voltage, so the amp draw. So I've got a solar charger up on the Bimini, or on the Dodger actually, and this is not an MPPT. So it just, the way that these work is they the amount of voltage that it needs, it usually rides just a little bit more than what the draw is. So kind of cycling through this, right now it's pulling, there's 20.4 volts at the panel with the sun. There's 0 amps coming in because I'm not using anything right now, and there's 2.5 kilowatt hours is what I've actually charged. The battery's at 14.4 volts and it's 20 degrees. And actually that's mainly because I've got also a battery charger in here that's connected to shore power when I'm at the marina. But so this will actually show me now 14.1, 14.0. So those are running, this battery I think is about 13.7 volts. So then I got my digital meter over here, and this is showing me the current draw, the battery capacity, that kind of thing. So when I turn on the lights, these 4 lights are drawing 1.4 amps total. And then see, now you can see it dropping. That's actually the solar charger kicking in and compensating for the draw of the lights during the day. So I think in contrast, the MPPT style controllers, what they do is they just try to peak out the voltage maximum on the input, and they convert it to the voltage that you need on the battery side. So they're probably, I think from what I understand, they're better in more southern climates because of the heat. So because I think the hotter things get, the lower the voltage, I think. But up here in Canada, right now it's end of September, and it's about 14 degrees Celsius outside. So yeah, it makes a big difference. I think that these ones work about maybe more efficiently here. So here's the actual light itself, and the other ones you can see. So I've got 4 lights running. That's what they look like. Yeah, actually I am pretty happy with them. So my display's turned off now because of my voltage draw. So now when I turn them off, you can see that actually the arrow changed to this direction. So that was actually pulling in now 1.2 amps of charge from the solar panel. And because the draw isn't needed now, the solar charger controller has actually cut off the charging, so it's not overcharging the batteries because they're fully charged right now. And I only have one 100 watt panel. It's a Renogy solar panel. I'll show you that. And it's just in here temporarily until I get my stand built. So basically that's a 100 watt fixed panel, and I'm using this to provide just some supplementary charging while I'm not plugged in. And what I found was that my old incandescent light bulbs from my lighting was actually more, because with my running lights, the bow lights, the stern, the anchor, and the mast light, I was actually drawing 5 amps, which is what this one panel can do. So, and that's with full sun all the time. So running my lights at night required 72 amp hours, and I only have a 100 amp hour battery. So that's my next project. Actually, I'm going to be changing over to lithium ion and then getting ready to change my engine over to electric. I'm going to be going with an electric motor, and I'm going to try to get about 400 to 800 amp hours is what my goal is with lithium ion batteries. So we'll see how that goes next. But anyways, I just want to give you guys an update on this. Actually, these are really cool. They cut my power draw down by immense, so from 5.5 amps to 1 amp basically. I think it was 0.9 or 1.2. It's kind of when they, but running they were about 0.9 amps when I watched them for a while, and that's a huge difference for 4 cabin lights. Yeah, and that's my update. Last update. Check this out. I got a little dimmer switch here. So here's my mood lighting, or my cabin mood lighting. I guess it's nice and calm, a little intense, nice and calm. So these things are dimmable. Alright, so it's the last sign off here for the light project. Just wanted to show the lighting at night. This is with the dimmer switch, so it's pretty black. And this is about how far down I can get them there, so they're pretty faint. You can definitely still see the light in it, and I can see like everything in the room, and but they aren't flickering or anything. And then just like a little bit more. My dimmer switch is a little sensitive here, and then cranking it up, that's actually how bright they get. And at full brightness, it says it's drawing 0.7 amps. And I just have this temporarily set up here, but this is actually the dimmer switch. And all the way down, it actually turns it off. That way I can control the lights separately. Another one on order, a touch switch here that you kind of go like this to turn it up and down. So I'm going to install that there for the lighting, but this is just temporary. I think I got that from an LED light strip kit. So I just chopped the ends off and just used it there. So that's it. Just wanted to sign off. Nice and bright at night. And I don't usually keep it up at full brightness because it's way too bright. I have to bring it down to here. And then I'm not drawing enough to register. So yeah, it's a big deal. Or a big improvement. So signing off. Until next video.